Before we dive into the depths where courage was measured not in words, but in the steady pressure of fingertips against cold steel, I want to ask you something. If you're here because stories of real human bravery matter to you, because you believe the most extraordinary moments in history deserve to be remembered, then subscribe to this channel right now. Hit that button. These stories don't tell themselves, and your subscription ensures we can keep bringing them to light. Because what you're about to hear isn't fiction. It's the story of men who descended into absolute darkness, guided only by touch, racing against time and enemy fire to prevent catastrophe. Now let's go back. The water was black. Not the darkness you experience when you close your eyes in a dim room, but a complete erasure of sight so total that opening or closing your eyes made no difference whatsoever. Thomas Brennan felt the thick rubber of his diving suit press against his chest as he sank deeper into Portsmouth Harbor on a March morning in 1944. The suit was heavy, the lead boots anchoring his feet to the harbor floor with each shuffling step. Above him, somewhere beyond the ceiling of churning sediment and oil-slicked water, dawn was breaking over England. Down here, there was no dawn. There was only the muffled rhythm of his own breathing through the rebreather apparatus, the pressure of water against every surface of his body, and the cable. His gloved hand never left that cable. It was a lifeline in more ways than one. 3 inches of rubber-coated steel running along the harbor bottom, installed weeks earlier by the Royal Navy to mark the safe passage between wharfs. But tonight it served a different purpose. Somewhere along this cable, intelligence suggested a delayed action mine had been placed by a German saboteur or dropped during the last air raid. The harbor master couldn't risk evacuation. Too many vessels, too much movement, too much at stake with the invasion approaching. So they sent Brennan and his partner, McAllister, down into the black. Brennan's fingers traced the cable's surface with methodical patience. Every few feet he would stop, run his palm along the circumference, check for anything irregular. A splice. A wire. A junction box that shouldn't exist. In training at HMS Vernon, they had practiced this in clear water tanks, eyes open, watching their own hands work. Then they practiced blindfolded. Then in churned water. Then with instructors firing blank rounds overhead to simulate pressure. None of it prepared you for this. The real thing had a weight that training could never replicate. The knowledge that one wrong identification, one missed wire, one moment of distraction could end everything. McAllister was 30 feet behind him, connected by a secondary line, moving in synchronized rhythm. They communicated through the tether with a code developed over months of dangerous work. 1 sharp tug meant stop. 2 meant proceed. 3 meant surface immediately. 4 meant trouble. The silence between them was profound, broken only by the distant throb of machinery on the surface and the occasional muffled boom of depth charges being tested in the channel beyond the breakwater. Those sounds traveled through water with a clarity that was almost painful, sharp concussive waves that rattled your teeth and reminded you how vulnerable human flesh was in this environment. Brennan's hand stopped. There was something. Not on the cable itself, but adjacent to it, perhaps 8 inches away. His fingers had brushed against a shape, metallic, angular. He froze completely, controlling his breathing, forcing himself to stillness despite the instinct to recoil. Slowly, with movements practiced 1,000 times, he extended his left hand while his right maintained contact with the guide cable. His fingers found the object again. Cold metal. Cylindrical. Roughly 2 feet long. Ridges along one surface. This was it. The mine was German, probably a GZ-type delayed action device, designed to rest on the seabed and detonate hours or days after placement when ship traffic was heaviest. Brennan's heartbeat accelerated despite his training. He could feel it in his throat, in his temples. He gave the tether 1 sharp tug. Stop. Behind him, McAllister would be holding position, waiting. Brennan began the tactile examination that would determine whether they lived or died in the next few minutes. His fingers traced the cylinder's circumference. 32 inches, he estimated. Standard naval mine casing. The ridges were casting marks, not threads. That was good. No immediate indication of anti-handling devices on the exterior. He moved his hand toward what he believed was the top of the device, searching for the fuse well. There. A circular depression, perhaps 4 inches across. His fingertips found the edge, explored the rim. No tripwires. No secondary mechanisms that he could detect. But detection by touch alone was never certain. Never absolute. Above them, on the surface, a motor launch passed overhead. The propeller wash created a current that pushed Brennan sideways, and for a moment he lost contact with both the mine and the guide cable. Panic flared. His hands swept through the black water, finding nothing, the disorientation complete. Then his shoulder hit something solid, the cable, and he grabbed it with both hands, pulling himself down, relocating the mine through memory and careful searching. His breathing was rapid now, the rebreather recycling carbon dioxide that tasted metallic and stale. He forced himself to slow down, to breathe through his nose, to count. 1, 2, 3, 4. The fuse well required delicate work. Brennan carried a specialized toolkit on his belt, each instrument secured by lanyard. He couldn't see the tools any more than he could see the mine. Everything was done by touch, by memory, by an almost supernatural sensitivity that developed only through repetition and survival. He unclipped the fuse extractor, a device that looked like a modified pipe wrench with rubber-coated jaws. Finding the fuse housing by feel, he positioned the extractor and began to apply pressure. The mechanism inside the mine was spring-loaded. Too much force, and the springs would compress, triggering the detonator. Too little, and the fuse wouldn't release. The correct pressure was something you learned to recognize through your hands, through the subtle feedback of metal against metal transmitted through water and rubber and bone. 3/4 of a turn. The fuse shifted. Half a turn more. It was coming loose. Brennan's entire world contracted to that single point of contact, his whole consciousness focused on the resistance he felt through the tool. Behind him, McAllister remained motionless, trusting his partner's skill, ready to assist or flee depending on what the next seconds brought. The water around them was so cold that even through the heavy suit, Brennan could feel it leaching heat from his core. His hands were beginning to go numb, the fine motor control he needed slipping away degree by degree. One more turn. The fuse came free. Brennan held it carefully, feeling its weight, the knowledge that this small cylinder contained enough explosive to vaporize both of them and crack the hull of any ship within 50 yards. He secured it in a padded container on his belt, then returned to the mine casing itself. Without the fuse, it was inert, but protocol demanded verification. He ran his hands over every surface, checking for secondary devices, for surprises the Germans might have engineered for careless disposal teams. Nothing. The mine was safe. 2 tugs on the tether. Proceed. McAllister moved up beside him, and together they rigged lifting lines to the mine casing, preparing it for recovery by the surface team. The work took 15 minutes, all of it performed in absolute darkness, their movements coordinated through touch and practiced routine. When the lines were secure, Brennan gave 3 tugs on his main tether to the surface. Haul away. They felt the vibration as the winch above took up slack, then the mine lifted off the bottom, disappearing upward into the black. They followed the guide cable back to the ladder, ascending slowly to avoid the bends, the nitrogen in their blood expanding as pressure decreased. The darkness gradually shifted from absolute to merely opaque as they rose, and finally, 20 feet from the surface, Brennan saw light for the first time in over an hour. It was gray and diffuse, filtered through oil and sediment, but it was light. His eyes, adjusted to total darkness, found it almost painful. They broke the surface together, pulled their masks aside, and breathed air that tasted of diesel and salt and life. The officer on the dock was Lieutenant Harrison, a man who had sent dozens of divers down into darkness and watched them come back up or not. He helped Brennan onto the ladder, steady hand on his shoulder. Status. GZ type disarmed. Fuse is in the container. Mine's on the crane. Brennan's voice was rough from the dry, recycled air of the rebreather. Harrison nodded. Well done. T's waiting in the shed. Take an hour, then we've got another one. Sonar picked up a signature near the ammunition dock. McAllister, climbing up behind Brennan, laughed without humor. Of course they did. This was the pattern throughout the spring of 1944. The Germans knew the invasion was coming, and they made every effort to disrupt the massive naval buildup along Britain's southern coast. Mines were dropped by aircraft, placed by saboteurs, and sometimes simply migrated on currents from older minefields. The work of clearing them fell to men like Brennan and McAllister, divers who operated in conditions that made visual identification impossible. They worked by cable following, by tactile recognition, by a kind of blind confidence that came from training and necessity in equal measure. In the Mediterranean, the challenges were different but no less deadly. The waters around Malta and Sicily held wrecks from years of naval warfare, debris fields where every twisted piece of metal could be a threat or just another fragment of a destroyed ship. American diver James Costello learned to read the seabed through his hands during the Sicily campaign, following anchor chains and mooring lines through water so murky with silt that visibility extended perhaps 6 inches on a good day. Costello's technique was different from the British approach. The U.S. Navy had developed its own doctrine, emphasizing speed over caution when circumstances demanded it. In Palermo Harbor, after the Allied capture of the port, Costello and his team were tasked with clearing unexploded ordnance from shipping lanes. The Germans had mined the harbor during their retreat, using a combination of conventional contact mines and sophisticated magnetic mines that responded to ships' hulls passing overhead. The magnetic mines were nearly impossible to detect by touch alone, but the contact mines could be identified and disarmed if you knew what to look for. Costello descended into Palermo Harbor on a July afternoon, the water warm but clouded with sewage and runoff from the damaged city. He followed a weighted line to the bottom, his hands trailing the rope's rough surface, feeling the knots that marked depth at 10-foot intervals. At 60 feet, his boots touched mud. He knelt there for a moment, adjusting to the absolute darkness, letting his other senses compensate for the loss of sight. The water had a taste metallic and organic that came through the mouthpiece of his breathing rig. He could hear his heartbeat and the mechanical clicking of the check valves in his regulator. The search pattern was methodical. He would move 20 feet in one direction, feeling the bottom with his hands, then return to the weighted line and move 20 feet in a perpendicular direction, quartering the area in a grid. It was slow work, exhausting, every movement requiring conscious thought because disorientation and zero visibility could lead you to swim in circles or lose the line entirely. After 30 minutes, his hands found something. A cable, thick as a man's wrist, partially buried in mud. He followed it carefully, excavating with his hands, tracing its length. Cables meant something, junction points, electrical connections. The Germans were efficient, their mine laying followed patterns. The cable led to a metal housing, roughly the size of a footlocker, buried in sediment. Costello's pulse quickened. This was a magnetic mine, the kind that sat on the bottom, and sensed ships passing overhead through changes in the local magnetic field. Disarming them required locating the sensor unit and interrupting its power supply. He began clearing mud from a housing, working by feel, his fingers mapping every surface, every bolt, every seam. The housing had a lid secured by 8 bolts. He unclipped a wrench from his tool belt, found the first bolt by touch, and began to work it loose. Above him, the war continued. He could hear the rumble of heavy trucks on the docks, the shouts of men, the metallic clang of cargo being loaded. All of it filtered through 60 feet of water, distant and unreal. Down here, the only reality was metal and mud and the steady work of his hands. The first bolt came free. Then the second. On the third bolt, his wrench slipped and his knuckles scraped against the rough casting of the mine housing. Even through the glove, he felt the impact, a sharp pain that cleared his mind wonderfully. He repositioned the wrench and continued. 8 bolts removed. The lid was heavy, but it lifted free with steady pressure. Inside, completely invisible to him, was the mechanism that could send half a ton of explosive compound into instantaneous detonation. His hands explored the interior with the delicacy of a surgeon, feeling for the sensor unit. It would be mounted centrally, suspended on springs to isolate it from vibration. There, his fingers found the cylindrical housing, traced its connections. 2 wires running to the battery pack, 1 wire running to the detonator. He followed the battery connections first, tracing them to their terminals. With a pair of insulated cutters, moving slowly, he positioned the jaws over the first wire and squeezed. The wire parted. No explosion. He cut the second battery wire. Still nothing. The mine was now inert, its power supply interrupted, but Costello wasn't finished. He needed to remove the detonator itself to ensure complete safety. The detonator was mounted on the bottom of the sensor unit, accessible through a small panel. His fingers found the panel, felt for the retaining screws. There were 4, each one requiring careful attention. As he worked, a current began to push at him, probably from a ship's propellers somewhere in the harbor. He braced himself against the mine housing, holding position, keeping his hands steady despite the water pressure trying to move him. The screws came out one by one. The panel lifted away. His fingers entered the space beneath, found the detonator, felt its shape. It was a standard German naval detonator, cylindrical, about 4 inches long. He grasped it carefully and pulled. It came free with a soft click that he felt more than heard. Costello secured the detonator in his thigh pouch, replaced the panel, and marked the mine's position with a small buoy on a weighted line. The recovery team would bring it up later, but for now it was safe. He tugged his safety line twice, signaling his intention to surface, and began the slow ascent, following the weighted line hand over hand, pausing at 20 feet for decompression, finally breaking into sunlight and air that felt like a gift. His team leader, a grizzled chief petty officer named Kowalski, helped him aboard the small boat. Got one. Magnetic German, about 60 feet down. Marked it with a red buoy. Kowalski nodded. That's 3 today. Harbor Master wants another sweep of the eastern basin tomorrow. Says there's more. There's always more, Costello said, pulling off his mask, letting the warm Sicilian sun hit his face. The work continued through the summer and into autumn. Sicily, then Italy proper, then the long preparation for southern France. Every port, every harbor, every anchorage had to be cleared before it could be used for the massive logistics that sustained the Allied advance. The divers worked in teams, developing techniques through trial and error, learning from each other's mistakes when those mistakes weren't fatal, adapting to local conditions and enemy tactics. In the Pacific, the challenges multiplied. The Japanese used different mine designs, different deployment strategies. The water was warmer, which was a blessing, but the currents were often stronger, the visibility somehow even worse despite clearer water, because the coral sand stirred up by tropical storms could stay suspended for days. Chief Petty Officer Richard Yamada, a Japanese-American serving in the Navy despite the internment of his family, became one of the most skilled cable-following divers in the Pacific Fleet. Yamada's specialty was clearance diving in advance of amphibious operations. Before Marines hit a beach, before landing craft approached a harbor, Yamada and his team would go in at night, swimming underwater, following cables and anchor chains to locate and map Japanese defensive positions. Sometimes they found mines. Sometimes they found cables leading to shore-based detonation points where Japanese engineers waited to blow obstacles when the landing began. Yamada's job was to follow those cables back to their source and cut them, disabling the defensive network before it could be activated. On Okinawa, in April 1945, Yamada descended into the water off Naha Harbor 2 hours before dawn. The water was bathwater warm, but that brought no comfort. He carried a knife, a pair of cutters, and a small explosive charge for emergencies. His orders were simple. Follow the cable network, cut as many connections as possible, return before first light. Intelligence suggested the Japanese had mined the harbor approaches and rigged the mines to fire from shore positions. Yamada's job was to make those preparations useless. He swam underwater for 20 minutes, following the coastline by compass, before his hands found the first cable. It was thinner than European cables, woven steel about an inch in diameter, running along the bottom parallel to shore. He followed it westward, moving slowly, stopping every few feet to check for branches or junctions. The cable led to a concrete anchor block, then branched into 3 directions. Yamada chose the southern branch, following it deeper into the harbor. The darkness was absolute. Even in tropical water, even with the moon overhead, the harbor bottom at 40 feet was completely black. Yamada navigated by touch, his left hand on the cable, his right hand sweeping ahead to detect obstacles. His fingers found another junction, this one more complex. 4 cables meeting at a metal box, roughly cube-shaped, bolted to a steel frame. This was a distribution point, probably connected to shore through one cable, feeding out to mines through the others. Yamada ran his hands over the box's surface, feeling for access panels, for weak points. The box was sealed, welded shut, no obvious way to open it. He pulled the cutters from his belt and went to work on the cables themselves. The first cable was taut, under tension, which made cutting it dangerous. If it snapped, the recoil could break bones. Yamada braced himself against the steel frame, positioned the cutter jaws, and squeezed with both hands. The cable resisted, then gave, parting with a vibration he felt through the water. The severed ends whipped away, disappearing into darkness. He moved to the second cable, repeated the process. Then the third. The fourth cable was different, thicker, and he realized it was the main line running to shore. Cutting this one would disconnect the entire network. As he positioned the cutters, something changed in the water. A new sound, high-pitched, mechanical. A boat motor approaching fast. Yamada froze, listening, trying to determine direction. The sound grew louder, closer. Then it passed overhead, perhaps 30 feet above him, and he felt the pressure wave from the propeller. A patrol boat, Japanese, probably checking their defensive preparations. If they discovered someone in the water, they would respond with depth charges, with small arms fire, with everything they had. Yamada remained motionless, barely breathing, letting the boat pass. The sound faded eastward, back toward shore. He returned to work on the main cable. This time, when the cutters bit through, there was a different sensation, a sudden release of tension, and somewhere in the darkness machinery shifted, connections broke. The defensive network was compromised. Not destroyed, but damaged enough that the Japanese would find significant portions of their minefield unresponsive when they tried to activate it during the landing. Yamada tucked the cutters away and began swimming back toward the rendezvous point, following his compass, counting strokes, trusting his training and his sense of direction in the absolute dark. He surfaced 200 yards offshore, precisely where the extraction team waited in a blacked-out boat. They pulled him aboard, silent, efficient, and motored away from the coast before the sky began to lighten. Yamada said nothing during the return journey, conserving energy, already thinking about the next dive, the next cable network, the next harbor that needed clearing before men could die on its beaches. The techniques developed by these divers, through months and years of dangerous work, became doctrine. Cable following as a navigation method. Tactile identification of explosive devices. Working in zero visibility as a standard procedure rather than an emergency situation. The British formalized it at HMS Vernon, creating training programs that emphasized sensory substitution, teaching divers to trust their hands more than their eyes. The Americans incorporated it into their underwater demolition teams, the predecessors of the modern SEALs, men who specialized in pre-invasion reconnaissance and obstacle clearance. But the training, however rigorous, could never fully prepare someone for the reality of the work. The psychological pressure of working in absolute darkness, knowing that any mistake could be instantly fatal, created a unique kind of stress. Divers developed coping mechanisms, rituals, superstitions. Some talked themselves through the work, a constant internal monologue describing every action. Others worked in complete mental silence, letting their hands operate on pure trained instinct. Many checked and rechecked obsessively, feeling the same connection 10 times before trusting that it was safe. A few developed a kind of fatalistic calm, accepting that death was a possibility and working around it rather than fighting it. The physical toll was also severe. Hours in cold water, weighted down by heavy equipment, breathing recycled air that was never quite clean enough, working with hands that gradually lost fine sensation as cold and compression affected circulation. Divers age quickly in this work. Their hands developed permanent tremors. Their hearing degraded from repeated concussive exposure. Their lungs showed scarring from high-pressure breathing. Many developed what would later be recognized as post-traumatic stress, nightmares of drowning, of darkness, of unseen things touching them in deep water. But they continued because the work was essential. The war depended on logistics, on ships moving safely through harbors, on ports operating without the constant threat of catastrophic explosion. The divers made that possible. Their work was usually invisible, credited to no one, mentioned in no dispatches. When a mine was successfully disarmed, when a harbor was cleared, when ships passed through safely, the divers moved on to the next job without ceremony or recognition. In the final months of the war, as Allied forces pushed into Germany itself, divers cleared the Rhine, the canals, the river ports that the Germans had mined and sabotaged during their retreat. The water was cold, nearly freezing, thick with industrial pollutants and debris. British diver William Thornton spent 3 weeks in March 1945 working the canal system around Hamburg, following cables through water that was literally toxic, finding and disarming demolition charges that the Germans had placed to deny the Allies' use of the transportation network. Thornton developed a method for working in the polluted water. He would dive for no more than 30 minutes at a time, surface, rinse his suit with clean water, change his rebreather cartridge, then go back down. The chemical burns on his hands and face healed slowly, but the work continued. Each charge he found and disarmed was another bridge saved, another dock preserved, another piece of infrastructure that would help rebuild Germany after the war ended. It was grimly ironic work, protecting the very facilities that had served German industry throughout the conflict, but Thornton understood the larger picture. Someone would need these canals, these ports, these bridges, when the shooting stopped. On his final dive in Hamburg, Thornton followed a cable into a submerged warehouse, a cavernous space filled with floating debris and collapsed shelving. The cable led to a junction box mounted on what had been the warehouse floor, now 6 feet underwater. He examined the box by feel, recognizing it as a central detonation point for multiple charges distributed throughout the building. Disarming it would be complex, requiring careful sequence work, cutting specific connections in the right order. He began the process, working methodically, counting wires by touch, snipping them one at a time. On the 7th wire, something went wrong. There was a spark he felt more than saw, a sudden heat through his glove, and the junction box went silent in a way that suggested catastrophic failure rather than successful disarmament. Thornton pulled back, waiting, expecting detonation. Nothing happened. He reached forward again, carefully checking the connections. The box had short-circuited, a manufacturing flaw or water damage, and in failing had rendered itself inert. Pure luck, the kind that kept you alive when skill ran out. Thornton marked the location, surfaced, reported the find, and watched as engineers brought up the junction box and confirmed that it was, indeed, safely disabled by accident rather than design. "You've got God watching out for you, Thornton," his commanding officer said. "Or I'm too dumb to know when I should be dead," Thornton replied, which got a laugh from the other divers, the kind of dark humor that characterized men who worked with death as a daily companion. When the war ended, the work didn't. Europe's ports and harbors were littered with unexploded ordnance, mines, charges, booby traps left behind by retreating German forces. The clearing operations continued through 1945, 1946, into 1947. Divers from multiple nations worked together now, sharing techniques, comparing notes on German and Japanese mine designs, developing the civilian applications of clearance diving. Some men stayed in the service, becoming instructors, passing on their knowledge to a new generation. Others left, returning to civilian life, but carrying the skills they had learned into commercial salvage work, underwater construction, oil field diving in the Gulf of Mexico. Thomas Brennan, who had disarmed that first mine in Portsmouth Harbor in March 1944, made 73 dives during the war. He survived them all, though his service record showed 2 hospitalizations for decompression sickness and 1 near-fatal encounter with a mine that was supposed to be inert but wasn't. After demobilization, he went to work for a Scottish salvage company, spending another 2 decades underwater, this time recovering ships and cargo rather than disarming explosives. He never talked much about his wartime service, preferring to let the work speak for itself, which was typical of the divers. They had done what was necessary, in conditions that were unimaginable to people who hadn't been there, and that was sufficient. James Costello stayed in the Navy, eventually reaching the rank of Master Chief and serving as the senior instructor at the Navy's diving school in Washington. He trained hundreds of divers, teaching them cable-following techniques, tactile identification, working in zero visibility. His lectures were famous for their practical focus and complete lack of bravado. You go down. You do the job. You come back up. That's all there is, he would tell new students. The water doesn't care how brave you are. The mind doesn't care about your feelings. You work careful or you work dead. Those are the choices. Richard Yamada faced additional challenges after the war, the ongoing prejudice against Japanese Americans despite his service record. He left the Navy in 1946 and worked as a commercial diver in San Francisco Bay, specializing in bridge pier inspections and underwater welding. He became an advocate for Nisei veterans, fighting for recognition and benefits that had been denied to Japanese-American servicemen. His wartime diving record remained classified for decades, only becoming public in the 1970s when historians began documenting the contributions of minority soldiers and sailors. The equipment they used evolved rapidly after the war. The heavy canvas suits gave way to lighter rubberized fabric. The rebreathers became more reliable, less prone to carbon dioxide buildup. Diving masks improved, though visibility remained a challenge in turbid water. But the fundamental technique, following cables and working by touch, remained essential. Even with modern equipment, even with sonar and underwater lights and communication systems, there are still times when a diver must work in conditions that eliminate sight and rely entirely on tactile feedback. The legacy of these wartime divers extends beyond technique and equipment. They demonstrated that humans could function in environments that seemed completely hostile to human presence, that training and discipline could overcome sensory deprivation, that courage could be measured and quiet and methodical. They worked without audience, without recognition, in darkness absolute and complete. Their victories were negative outcomes, disasters prevented, explosions that never happened, ships that passed safely through water that should have killed them. History remembers the battles, the invasions, the strategic decisions. It rarely remembers the men who made those operations possible by descending into darkness and following cables by touch to find and disarm the weapons that could have changed everything. Today, when military divers train for mine clearance operations, when commercial divers prepare for underwater construction in zero visibility, when rescue divers practice working in flooded spaces, they are following methodologies developed in the harbors and anchorages of World War II. The cable-following technique, the tactile identification protocols, the psychological preparation for working blind, all of it traces back to men like Brennan and Costello and Yamada, men who had to invent solutions as they went because there was no playbook for what they faced. The physics of sound underwater, the way pressure affects human physiology, the chemistry of explosive compounds, all of this was understood in the 1940s. But applying that knowledge in practical situations, under fire, with lives at stake, required a different kind of expertise. It required the ability to stay calm when every instinct screamed for panic, to work methodically when speed seemed essential, to trust your hands when your mind insisted that you were helpless. These were not superhuman men. They were ordinary people placed in extraordinary circumstances who found within themselves capabilities they hadn't known existed. There's a photograph, taken in 1945, of a diving crew at Plymouth. 9 men in their heavy canvas suits, standing on a dock, holding their brass helmets. They look young, which they were, most of them under 25. Their faces show exhaustion, the deep weariness that comes from sustained danger, but also something else. A kind of quiet confidence, the knowledge that they had done work that mattered, that their efforts had saved lives even if those lives never knew it. Behind them, in the harbor, ships are anchored, their hulls intact, their cargo secure, because these men had gone down into darkness and followed cables to find and disarm the weapons that threatened them. The photograph doesn't show the water, doesn't capture the darkness, can't convey the sensation of working blind in an environment where any mistake could be fatal. But the faces of those men suggest they remember. They carry it with them, the weight of what they did, the reality of working in absolute blackness, guided only by touch and training, and the desperate hope that their hands would recognize danger before it destroyed them. So if this story moved you, if you found yourself holding your breath imagining what it was like to follow a cable into darkness, if you want to make sure that stories like this continue to be told, then do one simple thing. Subscribe to this channel. Click that button right now. These stories matter. The men who live them deserve to be remembered, not as statistics in a war report, but as human beings who faced impossible situations and found ways to survive and succeed. Your subscription means we can keep bringing these stories to you, keep honoring the courage of people who did extraordinary things without asking for recognition. So subscribe, because darkness may have been their working environment, but their legacy deserves to be brought into the light.